Let's see guys, in this video we are going to discuss about the differences between concentrated winding and distributed winding. To know the concept of concentrated winding and distributed winding, we must know the definition of what is phase belt and what is phase spread. Generally, the phase belt nothing but the number of slots per pole per phase. This is what exact definition of phase belt. So generally the phase belt M is equals to number of slots per pole per phase. This is simply called as phase belt. Then what is phase spread? Phase spread nothing but the angle made by phase belt itself. What is that? The angle made by phase belt is called phase spread, simply M beta. That is M multiplied with beta. What is its value generally? The phase spread value is equals to 180 degrees upon M, where M is the number of phases. Remember this formula. This is not order of the harmonics, this is number of phases. For example, for a single phase machines, the phase spread is equals to 180 upon 1, which is equals to 180 degrees. For a two-phase machine, the phase belt is equals to 180 upon 2, which is equals to 90 degrees. For a three-phase machine, the phase belt is equals to 180 upon 3, which is equals to 60 degrees. Remember that for a three-phase machines, the phase spread M beta is equals to 60 degrees. This is also called narrow phase spread. Okay, remember this word? Narrow phase spread. Narrow phase spread nothing but the phase spread is equals to 60 degrees. Then what is broad phase spread? I will explain you in the next video. Okay, so see here. So now what we know that what is phase belt and what is phase spread. From that we can conclude that what is concentrated winding. What is concentrated winding and what is distributed winding. Distributed winding. So can you tell me what is concentrated winding? The winding in which the phase belt is equals to 1 is called concentrated winding. The winding in which the phase belt is greater than 1 is called distributed winding. This is simply what the definition of concentrated winding and distributed winding. Generally, in concentrated winding, EMF is more. In distributed winding, EMF is less, even though we are using distributed winding. Why? Yeah, the same reason. Here, EMF more, but not sinusoidal. Here, EMF less, but sinusoidal. Sir, what is the reason, sir? Already we eliminated. What we eliminated? Already we eliminated lower order harmonics. Then again, why this is not sinusoidal? Very simple. Because of higher order harmonics. Because of higher order harmonics, these are not sinusoidal. This will not produce sinusoidal EMF. Here, higher order harmonics are eliminated. That's why here the EMF is a sinusoidal. This is the main differences between concentrated winding and distributed winding. Sir, why it is called concentrated winding? Why it is called distributed winding? Let's see. You can easily identify why this is called concentrated, why this is called distributed. Once see, for example, I am taking one example here. A 3-phase 50H 6-pole 18 slots alternator. This is my alternator. Let's see how many poles are there. 6 poles are there. How many slots are there? 18 slots are there. What is slots per each pole? The slots per each pole is equals to 3. Then what is phase belt? The phase belt is equals to slots per pole per phase. That is equals to slots for pole 3, and the number of phases also 3. 3 out of 3 is equals to 1, where M is equals to 1. That is concentrated winding. What is distributed winding? I am taking the same example. A 3-phase 50H 6-pole 36 slots alternator. I am taking this one. Yes, can you tell me how many slots are there? 36 slots. How many poles? 6 poles are there. What is slots per pole, guys? 36 out of 6, which is equal to 6. What is phase belt? The phase belt is equals to slots per pole per phase. That is 6 out of 3, which is equals to 2, which is greater than 1. When this is a greater than 1, that is called distributed. Let's see why it is called concentrated, why it is called distributed. This is your question. How many poles are there? 6 poles are there. 6 poles are there. For example, 6 poles are there. How many slots for each pole? The slots for pole 3. Slots for pole 3. How many poles are there? Here also 6 poles are there. How many slots for each pole? For each pole, I have a 6 slots. Each pole I have a 6 slots. So this is a 3-phase machine, right? When this is a 3-phase machine, we have a 3 phases. For example, these slots are reserved for R phase, this is for Y phase, this is for B phase. These 2 slots are reserved for R phase, this is for Y phase, and this is for B phase. Sir, what is the meaning of this? Here, slots per pole 3, but slots for pole for each phase is only 1, which M is equals to 1. Here slots for pole 6, but slots for pole for each phase is the 2. That is slots for pole per phase is equals to 2. For example, my alternator having 300 conductors. What? My alternator having 300 conductors. These 300 conductors are R phase, Y phase, and B phase. For example, if this alternator is this one, then what is the meaning of that? The R phase conductors of 100, the 100 R phase conductors are placed in one slot. But here, these 100 R phase conductors are distributed to 2 slots. These are distributed to 2 slots, each 50. The Y phase total 100 conductors are placed in one slot, but here the 100 are distributed to 2 slots. If M is equal to 3, distributed to 3 slots. If M is equal to 5, the 100 conductors are distributed to 5 slots of each 20. That is the concept actually. This is concentrated winding and this is distributed winding. Okay guys? Got it everyone? So this is the perfect example for concentrated winding and distributed winding. Now we need to go for distribution factor or phase belt factor or phase spread factor. In full pitch short pitch winding we have Kp, but here we have Kd. That is also important guys. Let's see that.